Hey guys! Hey guys, welcome to day 4. We're going to talk about what the surface area of a cone and a sphere are. In your e-learning packet, right, we're on day 4, so it should be sequentially after your day 3 on the cylinder. Remember, I've got extra copies of that posted on Google Classroom just in case you need to print a new copy. Our math meme of the day, I'm going to zoom in on our meme. It says the solid figure below can best be described as a Pac-Man. So a little Pac-Man humor there. For your formulas for the surface area of a cone and a sphere, if we go to our formula sheet, which remember is like the last page of your packet. So we've got our surface area section on top, our volume section on the bottom. So if you look at your surface area, it only lists what's called the lateral surface area of a cone. If I was to draw a cone for you guys, the lateral surface area would be all the outside bit, right? It would just not be your circle. So I'm going to just make it so that the lateral is just the yellow bit, not the green circle at the bottom. So it's just everything but your base. And we're going to talk about where that formula comes from, and I've got the formula written out on our note sheet. And you've also got a spot where you have the total surface area of a sphere as well. So I just wanted to point those out because they are there. You've got some space at the top of your note sheet to make a note about cone and sphere. So the total surface area of a sphere and the lateral surface area of a cone. So for a sphere, here's your formula. If you draw a picture of a sphere, right, you've got the radius of the bottom, the little circle, that's your base. You've got the height of the sphere, which is not the sphere. You've got the height of the cone, which is how tall it is from the center all the way straight up to the top. And then we have something what's called a slant height, or like the slant is what some people call it. So right there, that's your slant. And it's kind of like the diagonal slope side of your cone. Okay, it's kind of like if we go back to, if we go back to day 2, give it a second to load there. If we go back to day 2 ideas, this is like your slant height of your pyramid, right? I think if I go back to a previous one, there we go. So like this is like your slant height, the 7.8. The slant is kind of similar to that, if you think about it that way. Your formula's down here, it's a little bit down below. Your formula is the area of a circle, right? So it's your circle, which is pi r squared, and then plus the top bit that's on top of your circle. And that's pi times radius times your slant height. And that's all coming from the picture up above. I've actually got a video that walks us through how to find the surface area. And so I'm going to pop my screen over for a second just to show you where that is. So I've got a video, and it talks about how to find the surface area of a cone. In the reference library, which remember on my website, you go to the reference library option. If you go in there and choose reference library Google document, and then if you scroll all the way down, I'm in unit 9 surface area and volume. So if we go to surface area of a cone, I've pasted that video where they explain where that comes from. And then I've also got a video for the surface area of a sphere as well. But if you are curious, please watch the video. I think it would be a really good explanation. Another way you can draw what that piece of the cone is kind of looks like this. Kind of looks like a Pac-Man, I think of it. Picture it kind of if you were to like cut it along here, like picture it's kind of like a circus tent, right? So that's a circus tent. If you were to cut along and have it like open up a little bit, right, it would kind of look like a Pac-Man shape before you tape along the 2 dotted lines to make more of a tent shape. So there is a video where they walk you through just what's called, the yellow bit is the lateral, surface area. So that's why your formula sheet, it only gives you the lateral surface area. You have to make a note that you would add pi r squared if you want that as a reminder, because then you won't be getting your full surface area. Okay, but feel free to watch the video. I think it's really good. I would highly recommend it. Some of my students last year found like the explanation a little confusing, because it's like a little bit weird at first to understand. But I think this video actually did a really, really good job of explaining it, and I found it this year. So I'm hoping it's a better video. For the surface area of a sphere, it's actually 4 pi r squared for circles. So there's your formula. I'm going to show you guys the video on this one because I think this one's pretty quick and it's pretty self-explanatory. I've also added this to my reference library as well.
Okay, so we are exploring surface area of spheres by looking at an orange.
Okay, so she's got her orange.
The rounder the orange, the better, because that's going to make it the most similar to a sphere. Our first step is going to be to draw 4 circles. You're just going to lay your orange flat and use a marker to draw circles around the orange. It's okay if you're circle around the edge of that and make all 4 fit between. Now that I have my 4 circles drawn, the next step is going to be to take the surface of our sphere and try to fill these 4 circles if we can make it by peeling the orange. I found it easy. Also, you want to make sure that there's no white space, and so the easiest way to smallest pieces that you can. Third circle now. I've covered a little over orange taken up track. Okay, so I finally have covered.
So here you see at the end when she takes all her orange peel and layers it onto the circles. Remember, the circle size is based off of her orange size specifically, so that's why this works. But when she puts them, it turns out to be 4 circles, which is why the surface area is 4 times the area of a circle, pi r squared. Okay, so make sure you make a note. What I'll probably do is over here on the side, I'll just rewrite my formulas out just to have them as a reference. Okay, so I'm just going to put that there. So surface area of a sphere is 4 pi r squared. Surface area of a cone equals pi r squared. And that part's going to be just your circle. Plus pi times radius times slant height. And remember, that's kind of like the Pac-Man shape. Right? It's kind of like the tent that's been uncurled. So let's look at some examples. So number 1 and 2 are just like a couple straightforward examples. I'm going to first start with number 2, I think, because I think the surface area of a sphere is a lot easier to start with. So remember, it's 4 pi r squared. My radius here, I want just halfway across the circle, or excuse me, the sphere, or I guess you could think of it as the circle that's here in the middle. So my diameter is going to be 18, so my radius is half of that, or 9. So when I plug that in, it's going to be 4 times pi times 9 squared. It's going to be 4 times pi times 81. I'm going to multiply the 81 and the pi to get, or excuse me, the 81 and the 4, just my plain numbers. Looks like it's 324 pi. And then I'm going to put inches squared. So remember, inches squared, units squared, that's how we want to put our final answers for this unit. I'm going to leave it as 324 pi because I want the exact final answer. I don't want to round with decimals. For the next one, let's go back to number 1. I'm going to do it in 2 separate steps. So I'm going to first do the area of my circle. Okay, area of a circle is just the pi r squared. So pi times my radius, it tells me that 10, it looks like is the diameter. So I'm going to say my radius is 5. And it says 25 pi feet squared. And then I also want to get my tent, right? I want to get that tent. Now, here's the tricky thing. We need, I'm going to draw like, kind of like my little Pac-Man shape over here. For the surface area for this guy, we need pi times radius times slant height. Remember, slant height is kind of like this. It goes on the side. Now, they told us that the diameter is 10, so that's 5. Notice you've got a triangle, a right triangle here. If you do 5 squared plus 12 squared equals c squared, you'll find 169 is c squared. And what times itself is 169? Your slant height will be 13. So your surface area is going to be pi times radius of 5 times slant height of 13. And 13 times 5 is 65 pi. Now here's another really good reason why I leave them like that, because now that I've got my two parts that I want to put together, I'm just going to add the 65 pi plus the 25 pi, and that's going to give me 80 pi feet squared as my final answer. Oops, sorry about that. And that's why it's much easier to do it in this fashion, because it ensures that you'll get a nice, clean, exact answer. You can add them like terms, which is really nice. So there's like no rounding or anything, which I really prefer. Okay. So let's keep going. Number 3 is kind of an interesting shape. This one I would view as it's a composite shape. And if we look back at the directions, we just want the total surface area of each solid, right? So if you look on top, it's kind of like half of a sphere, another half of a sphere. So together, if you put the two halves together, right, you'll get one sphere. If you have trouble drawing a sphere, here's my tip. I draw a circle. I do a curved line in the middle, and then do a dotted line kind of behind it to show the other side of my sphere. So it looks like we've got a sphere, right? According to the picture, the radius is 6 meters. And then if we look in the middle, it looks like we've got a cylinder. Now, here's the tricky thing, and I'm going to just label my height as 11. My radius is 6, once again. Now, the tricky thing is when we are doing our surface area and whatnot, right, I want the total surface area of the sphere. I want the top half of the sphere, I want the bottom half, right? So I want all of that sphere. However, when I do my cylinder, I'm not counting the top circle and I'm not counting the bottom circle. Because notice, if you think of it like this is an object and you're putting wrapping paper around it, you'd only be wrapping around the side. You won't be wrapping on the circles because the sphere is on top of your circles. So that's why you won't be counting your circles. So let's do practice with a sphere. Our surface area, remember it was 4 circles, 4 times pi times radius of 6 squared. 4 times pi times 36. I do 4 times 36, it looks like it's 144 pi meters squared. And then I'm going to do my work for my cylinder here. So this is your lateral surface area of your cylinder. Remember, if you think of it like a can of soup, when you uncurl it, it's going to be a rectangle. The height is given as 11. The length of this rectangle, remember, that's the same as the circumference if you rewrap it. So 2 times pi times radius is going to be 2 times pi times 6, which we can call 12 pi. If I want the area of that, it's going to be base times height, so 12 pi times 11. So all you have to do really there is you're going to do 12 times 11, right? You don't have to worry about the pi or anything, so you've got 132 pi meters squared. And when you add the two together, that's going to be our total surface area. So 132 plus 144 is 276 pi meters squared. Notice, just like up above, both of these are in terms of pi. So please, please, please leave your work in terms of pi as you get answers throughout the problem, because it's a lot easier than rounding. Okay, so I'm going to pause there and we'll continue with the next page in video 2.